Who am I? I'm Jake Duckers. Most recently, I'm an assistant manager for business analytics at Spencer's, where I hold Databricks certifications as a machine learning engineer and a data analyst. And most recently, as you can see, I'm now a member of the MVP program. Now, I chose this picture myself because I thought it represents a data analyst workflow pretty well, and plus I think it looks pretty cool for myself. But you got the cool, processes right, you got your gear all set up, but then where's your data? This is just one of the many questions I hope to answer today by following along on my roadmap. Now, to begin our roadmap, we first have to understand where does a data analyst fit into Databricks? And I do this by breaking their role down to 3 domains. Gather and interpret available data resources to build data objects that will feed business use cases. These 3 domains I outline as the following, and I plan to define these 3 domains through the lens of an analyst. However, before we can even define the analyst roles, we have to first put physical properties to this idea of Unity Catalog, and the first place we can do that is by going to the catalog pane, as this is the first place an analyst is going to be able to see and touch it. And for simplicity, we're going to assume a single catalog following the 3-tier medallion structure of bronze, silver, and gold, where the analyst is going to be primarily concerned with what's in the gold layer, as these feed Power BI and key reports. As they mature, and data resources become available, they're going to start going into that silver layer to get more of those source tables. Now, what an analyst needs to understand is that as data objects move through this medallion structure, they are transformed and created and feed business use cases. Analysts should start envisioning how these data objects are transformed and created in the rules that govern them through these processes. Data discovery and data governance. Now, I'm going to skip through this slide, and let's just get right into it. All right, data discovery and data governance essentially boils down to where's my data, and what are the properties in its life cycles, and we can do all this through the Unity Catalog using the UI. Data discovery and governance I boiled down into 4 key pillars. Freshness, who or what is updating the object, and what is the cadence of these updates and refreshes. Volume, what is the size of the object, and how many files make it up. Lineage, what are the sources and how do they relate to the business use cases? And schema, what are the columns, data types, comments, and very importantly, the relationships. And we can address all these questions by using the catalog. This is our entry view when looking at an object in the catalog, in this case, a delta managed table. We can immediately determine if this object can be used for a business use case, or is it too stale based on its refresh schedule, or heavy because of the size of the data and would require further manipulation. We can go one step deeper into understanding an object's freshness by understanding who or what is created it and what is updating it by using the Details tab. And this gives ownership to the object and helps establish lines of communication with the proper teams. As an analyst grows, they can even take advantage of the Properties section to understand what table properties may need to be applied. And most recently, I found this out. When you want to do incremental refresh with materialized views, with specific SQL functions, you got to have row tracking enabled. Moving on, using the History tab, we can see what operations are being done and when, as well as what are the jobs, notebooks performing these operations. And depending on your permissions, we may even be able to see the job or the notebook that ran this. This builds on that communication I described earlier. By now we know what team we need to talk to, and we know what processes need to be reviewed before building on a business use case. Going right on over, looking at the Lineage tab, we can identify what are the upstream dependencies and how do they govern how this object is created or updated, as well as what other downstream business use cases does it solve. We can even further filter this to just dashboards, tables, and queries. Now, going back to that Overview tab, this view looks slightly different because we're looking at a different data object. In this case, a materialized view, and what this allows us to do, which is why I love Databricks, is I can see the SQL definition behind it. And from here, we can identify what are the data types, the column comments, and primary and foreign key relationships to understand the structure that govern this object's place in the business ecosystem. A key feature in Databricks that we can leverage is the Databricks AI Assistant to generate these table and column comments. And boy, can I tell you, that saves me a lot of time. We can also view the entity relationship diagram by using the UI feature View Relationships. Let's take a look at it. Here is the same materialized view as ERD with primary key and foreign key constraints established. I wanted to show this one because some examples are kind of basic, I wanted to show you can make a composite primary key made up of multiple columns as well as having multiple foreign keys on this thing. And now, I saved this slide for last because of the power that primary and foreign key relationships bring to Unity Catalog. As informational constraints, they help analysts understand the entity relationships and how to join those tables. By adding an enforced constraint and the rely option, they can be leveraged by BI tools for query optimization. Whew, that was a lot, sorry. I wanted to get through the basics before we started getting into the other stuff. So now we understand a data object's properties and the rules that govern their structures and potential use cases. We can explore our data and validate its ability to answer the business questions and requirements. Through this process, the analyst is going to go from running ad hoc queries in the SQL Editor to building data models using notebooks and workflows, or as I found out today, lake flows now. I define data transformations and modeling by their requirements. Defining EDA and data mapping in this context, especially for business, means validating aggregation metrics across dimensions to reflect business processes. And the SQL Editor and the notebooks provide the environment to do this in. Code can be run thanks to Databricks Compute, where we can attach to a serverless SQL warehouse and a serverless compute. And the choice can depend on the environment where the code is running, as well as what language you're coding in. We can review the data and math rules by utilizing the built-in features and defining constraints on our data objects. Now, the question comes, all right, you showed me all this. Where's all this stuff saved? In the Workspace tab. So I like to think of this as like the S drive of Databricks, where everything is saved. By having a centralized file system, we're able to create a hierarchical folder structure where we can organize our notebooks, our jobs, and our dashboards. And a key Databricks feature in the Workspace is the ability to connect and create Git folders so we can get all that perks of, a version-controlled code base when you guys are all ready. And I'm just going to toot my horn. That's my organization, so I like it. Now that we know where our queries, notebooks, and dashboards are saved, let's look at our first coding environment, the SQL Editor, as this is going to be where an analyst starts. Opening a previously saved query in the SQL Editor, we can see we have 4 separate queries within it. We can set the default catalog and schema, as you guys are seeing here, so we don't need to do the full data object reference when running the query. We have the ability to run selected queries, as well as limit our results. But for now, I'm going to run them all. Since we're chaining together multiple queries, this is going to produce a multi-tabbed result. We returned each table properties as well as the sales table because I wanted to highlight one of the core features for an analyst, the ability to build visualizations off your queried results. Here, we're going to make a simple line graph for, let's go with sales units by date. And then, for funsies, let's go ahead and group it by state so we can see all the state's historical performance. Once this thing looks pretty good, we're going to be able to save it to our SQL Editor. I like to always inspect how crazy it looks. Looks good. So now we can move on to scheduling this query. We're going to add a schedule. We can set the time zone when we want it to run. And then when we're ready for it, we can save it. And then when I want to inspect it and I'm ready to show it to my boss, I can then hit share and I can set his level of permissions. All right. As the analyst now goes beyond those ad hoc queries you just saw in the SQL Editor, they kind of want to now take those, from experience, 20 CTEs, make some temp views, maybe use some PySpark to do some more heavy data transformations. They're going to move into notebooks. Notebooks have the advantage of having separate code cells that can organize and structure their analyst code for readability and orchestration purposes. Looking at this notebook's table of contents, we can see it's an ETL notebook that's broken down into subsections to create the fact and dimension tables for this talk. Another advantage of notebooks are the ability to access different types of computes, such as serverless, as you can see here, which allows code cells to be written in different languages but still be able to run together. Here, I create the calendar dimension table using the SQL commands create or replace table and the insert into. But when we scroll a few lines down, you're going to be able to see that I actually create temp views using PySpark, which are then put into a SQL code block to finally make my sales table because I'm crazy. I wanted to show you. Now, just like the SQL Editor, we can create visualizations, we can organize our notebooks in the Workspace, and we can set a schedule for our notebooks. Now we're going to start getting into the picture slides. So this is the basic notebook structure I use to develop the core analytical tables that feed Power BI and our Databricks dashboards. Each notebook is broken down into three main parts. The first is you're going to make that table definition. It's your column list. And you're going to put your column names, the data types, enforced constraints, and primary key columns and comments. Enforced constraints ensure that the data that is added is automatically verified, and if it breaks that enforced constraint, the transaction will fail. Very helpful. Next, I encode the primary and foreign key relationships, but these are very, very important to remember, is they are only for informational purposes at this point, and they are not enforced on their own. The next thing I like to add is the rely constraint option for a primary key, because when it's valid, it can be leveraged by downstream BI tools, as well as improve query performance. And finally, you want to use automatic liquid clustering by cluster by auto. Second, I'm going to create the temp views, referencing my source tables in the silver schema to build my fact and dimension tables. Once I have all those temp views created, it's as simple as just using that SQL command insert into, and I'm going to insert all those temp views into it. This modular code structure allows for user readability, easy debugging, and future modification. Here's probably a slide we all want to see. This is the simplified example to create that sales fact table. The enforced constraint, not null, is set on the columns that are going to be used to make that composite primary key. That's that enforced constraint I've been talking about. When the primary key is valid, meaning it's unique, you can set that rely constraint on it. That rely constraint option allows the query engine to skip over the unnecessary joins when the join won't change the final result of that table or what it's going to pop out. Next, I do automatic liquid clustering by using cluster by auto, and finally use insert into to insert all that data into our defined table earlier. And if you want to validate everything that you've done in here, it's as simple as going back to that SQL editor and just typing in describe table extended in that table name. Orchestration. Now we know we have our notebooks created that form our data model. We need to ensure that our data is fresh and up to date for our business users. So we got two options here. You can either schedule all those individual notebooks, no. Or what we could do is use our workflow Lakeflow features now. Here's the workflow I set up originally for this talk. Using the Databricks workflow, I chained together multiple task types to orchestrate these notebooks that create my key reporting tables. Notebooks can be run in any specific, specified order by setting your task level dependencies. I included here an if-else condition because I wanted to demonstrate you can create complex workflows within Databricks. Now, the reason I put that in there is because I don't want to refresh my calendar table every single day when I'm refreshing my tables. I only want to do that once a year. That's what that if-then condition is meant to be used for. I just want to highlight here two things you might want to check out is the task type, the Power BI refresh, and then the Databricks dashboard refresh. Those I'm testing right now, and I'm loving them. From that view, if you guys back out in that workflow, you can see the overview of it. And this is where we can review past runs, we can modify triggers and schedules, and we can ensure proper monitoring by simply just applying those tags, because this will help with that cost monitoring and observability feature. A key feature here we can do from this view is set task level parameters that can be referenced by those individual tasks. So if you look over here, I have on the job parameters job run date. That's what's getting passed into that if-then condition and checking it against what is the current date. Now we're at our final domain, guys. Now that we have our data models built and we ensure their freshness, we're ready to build data products to deliver business value and insight. There are many different BI tools and last stops for data when delivering to the business, but I want to focus specifically on dashboarding. The first is Power BI. What can Power BI do with these column constraints and how they can be used to automatically generate that semantic model? And finally, I want to show off a Databricks dashboard. First, we got to set up our connection to Power BI and Databricks. We go to the workspace, we're going to go to the compute pane, and we're going to grab that SQL warehouse hostname and path. Then we're going to go on over to Power BI. We're going to go to Get Data, navigate search for Azure Databricks, and paste in that hostname and path. We're going to select our tables, load and transform the data. And then what you're going to see here is finally, once those tables load into Power BI, if we navigate over to the Model View tab, by establishing those primary and foreign key relationships, those are automatically generated for us. So no more do we have to go to the juniors and see many to relationships that are blowing up the models. Databricks dashboards are evolving at an exponential rate, and I want to highlight three features here. Databricks parameters, calculated dimensions and metrics in an auto-generated Genie space. This is a published Databricks dashboard using the Walmart data set from the M5 forecasting competition. At the top are our key filters. By picking different business-defined date periods, we can see how the visualizations are either rerunning or reading from cache by the spinning wheel that shows in the visualization. Next, we can see dynamic cascade filtering in action by changing the state filter to California, also filters down that chain to filter the stores, and we can also reverse back up that chain, as you can see when we filter to just a specific store in California, filters the state. Now, what I want to do here, once I finish showing this demonstration, there we go. Let's look at an auto-generated Genie space. Or sorry, yes, let's look at auto-generated Genie space from here. From the highlighted section of my prompt, we can see Genie uses the metadata from the table or column comments to translate last complete week into LCW, which is one of our business-defined periods. And Genie not only provides us a result as a table, but it's using the data visualizations within the workspace to provide me the type of visual I'm expecting. Finally, we can provide feedback. And it is noted that when you want to provide feedback to Genie, you don't just want to provide a rating, you also want to be able to provide specific corrections and context in order to improve future conversations. The first step to creating this dashboard is to create the data sets that power our visualizations using the Create from SQL option in the dashboard. Visualizations needing their own level of granularity are going to have their own data sets. And do not quote me, but I think you can have about 100 separate SQL queries in there. So if you reach it, let me know, because I want to know what you're doing. The second step is you can use that same star schema or a one big table from our visualization data sets to get your distinct choices for your filters. So you want to have in here data sets for your visualizations and then data sets for your filters. The dynamic cascade filtering I have to modify the where clause to be broken up into separate conditional arrays for each filter. This allows for that default catch when you're not doing any filtering and it's just like all. The way you reference them is now it is the colon parameter name notation. And if you look at the bottom of my image right there, if you want to change the parameter type, you're going to go to the parameter section. And what you have to do for each of those array conditions is you want to make sure it's multi-select. The date, single select, and then you can also, as you can see here, is a date range as you can choose as well. Returning to the canvas view and selecting the state filter, we can choose the state filter data set for the field section so we can actually see how we can interact with this thing. When we select each data set's corresponding, when we set this thing, we're going to pick the fields, which comes from our filter data set. Then remember how in that where clause we modified each of our things we want to filter? That's what you're going to choose for each of those parameters. That's how you enable that dynamic filtering that's going on. To create custom calculations as well as their comments, we're going to click back onto the schema tab, and we're going to click on the schema tab in the data pane. Custom calculations let you define dynamic metrics and transformations, and I want to highlight two main things about this stuff. Calculated measures are aggregated values. The example here is going to be revenue percent change. The second one is going to be a calculated measure, which gives you an aggregated result, and that's going to be your overall revenue percent change for that date period. The one thing I want to highlight here is these improve your dashboard's responsiveness, because if the data set's small that you're going to be using for the visualization, 100 megabytes or less than 100,000 rows, it happens in the browser. If it's got to go back to the SQL warehouse, you're going to see that spinning wheel. The last step in this process is publishing the dashboard. This is what I really want to see for a lot of these talks is how are now these businesses actually using Genie? Are they creating their own Genie space based on dashboards or building it right off the top? Here, we're building an auto-generated Genie space from a dashboard. So our first choice is our first choice is the auto-generated Genie space. The second one is going to be using that URL, and we can post it into a previously created Genie space. Now, I want to talk about the limitations here, and that's pretty much going to be it for it, is that if you use an auto-generated Genie space, from what I found, is you can't modify the instructions in the UI using Genie. But if you create a Genie space in its own environment, you're able to modify the instructions. So what I've seen is I will use a dashboard to kind of create a template of how I want this Genie space to be built. and the SQL queries I'm going to need, and then I transfer that into its own private Genie space, so then I can kind of get more particular with that tuning of those instructions. Lastly, I just wanted to provide some resources. I'm really loving this book. I think it's really good for every business analyst for talking about the gold schema. And I just found out from Andre that may be an old QR code, but if you're doing anything with Databricks and Power BI, that is going to be the GitHub to go to. It has all performance optimizations, how to kind of set things up. I highly recommend that. So if that QR code doesn't work, I'm sorry. Lastly, please complete the survey for my session. And thank you for coming, guys. I appreciate it.